Our final presentation will focus on science for success, and we are pleased to have Dr. Giovani Preza Fontes as our presenter. Before we begin, here are a few quick reminders. CCAs, please make sure to sign the sheet in the room to claim your CEU credits after the session. And this session is being live streamed on Field Advisor's YouTube channel, so feel free to share the link. Now to introduce our speaker. Dr. Giovani Preza Fontes leads the University of Illinois Field Crops Extension and Research Program, focusing on enhancing the agronomic and environmental performance of field crops in Illinois. His research involves evaluating and refining management practices aimed at increasing grain yield and nutrient use efficiency while reducing environmental impacts, such as nitrate leaching and greenhouse gas emissions. In addition to his research, he is responsible for teaching and extension outreach. Preza Fontes earned his bachelor's degree from the Federal University of Mato Grosso in Brazil, his master's degree in agronomy from Kansas State University, and his doctorate in crop sciences from the University of Illinois. Please join me in welcoming Dr. Giovani Preza Fontes.
Thank you. Hi, everyone. Wow, that got so loud, but sorry. How are you guys doing today? Pretty good, right? Well, first of all, I just want to say thank you to ISA for the invitation of me to come and talk to you guys a little bit about what is Science for Success. And I also want to thank you guys for sticking around until the end. I know it's been a long day, but a lot of great discussions. So, yeah, what I want to do today, and again, just try to keep things light, right? So we're towards the end of the day. What I want to do today is just talk a little bit about Science for Success, what Science for Success is, and what we do, and show you guys where you can find some of the resources that we've been putting together. And then at the end, I'm going to try and summarize one trial that we did together as a collaborative effort. So before I jump into that, I just also want to take the opportunity to kind of introduce myself if you haven't met me yet, or reintroduce myself. I'm a new faculty in the Department of Crop Sciences. I've been in this position for about 2 years now. I hold a 3-way appointment in the land grant system, so I get to do all the 3 jobs. And in addition of teaching in the department, I also have a 50% research appointment and a 30% extension appointment. So I also serve as the state agronomist. So most of my time when I'm not teaching, I am focusing on my research and outreach program. So what I'm trying to build here in Illinois, and I don't have a corny name for it, so I'm just calling it a Field Crops Research and Outreach Program. So basically, conducting field-applied research to provide research-based information to you guys, soybean growers and crop consultants and any other agricultural stakeholders, right? So basically, all the information on best management practices that are guide efficient, cost-effective, and environmentally sound management practices. This knowledge is then integrated and delivered through our Illinois extension programming. I'm also trying and take advantage of the social media, and I started building this website. It's called ilagronomy.info. So I encourage you guys to go and visit. It's a working process. This is a website that I'm trying to get up. It is already up, but I'm trying to fill with all the information that can help you guys. So basically summarizing some of the previous research that has been done in Illinois, and summarizing ongoing research that we're developing, and summarizing those results, and kind of providing recommendations and considerations for you guys. So there's a page with crop management. Again, it's a work in progress, but there you can find some information on corn and soybean management. And this is all based on research that has been done in the state. And again, being my extension appointment and being the extension agronomist too, I kind of serve as the leadership for any collaborative research and extension efforts, not only within Illinois, but also across the states, right? So that's what leads me to the Science for Success. I want to ask you guys, have any of you guys have heard about Science for Success before? Of course you have, right? What about you guys? You have? Would you try and explain what it is?
Collaboration of efforts among soybean safety specialists around the country to synergize efforts in different states and common problems and different.
Awesome. Thank you. Yeah, no, I will. But yeah, no, it's good to know that Science for Success is, the name is getting out and people are kind of knowing what we do. But basically, Science for Success is a project that is funded by United Soybean Board. And it brings together soybean researchers and extension agronomists from different land-grant institutions that kind of work together to, with the main goal of the project is to deliver best management practices for farmers and any stakeholders, right? So right now, I believe if I'm not mistaken, I think we have a team comprising of 26 different land-grant institutions, and you can see on the map right there on the bottom right, kind of gives you an idea of the extension of our group within the United States. We have folks all the way from North Dakota, all the way down to Louisiana and Florida, right? So our team, we cover about 90% of all the soybean acres in the United States. Our project leader is Dr. Rachel Van. She's a soybean extension specialist at North Carolina State University. She's actually a U of I alum. Right, she got her bachelor's degree from NRAS in the College of ACES. So again, the project goal is to deliver soybean best management practices. So how do we do that? Right, so basically we do that by doing the three different things, right? So we work together on basically summarizing existing and ongoing QSSB supported soybean checkoff research, right? So we do that. We have annual meetings where we get together and we work on extension materials. We write fact sheets. Actually, I brought a few copies of 5 fact sheets that we published in 2024. They're here in the table available for you guys to pick up. Collaboration on national research trials, right? So this is, I think, a big component on our group is the ability that we can to put standard protocols across the United States in a way that we can quickly generate information to address different topics, right? I'm going to talk a little bit more about that, but some of the research that we've done and we've been doing covers a wide range of topics. And lastly, we try to leverage our state level knowledge and bringing all that knowledge and trying to amplify into a national extension impact, right? So with that, we try to leverage social media. We have a YouTube channel. I'm going to talk a little bit more about that. We are engaged in Twitter or X right now. So we have our webinar series that we're going to go and talk more about that. So here's just a few examples of some of the resources that we put together, and it's available for you guys. This is one of the first ones that got published. It talks about soybean growth and development and talk about a little bit on the management and the misconception side. I guess it's a very good resources for everybody that is working with soybeans, and the QR code is there. If you want to scan, it's going to take you to that PDF. So I'll just wait a little bit for folks that are doing that. This is other examples of extension articles that we put together. We have a few talking about planting day, considerations for planting day. We have another one on replanting, right? So that we walk through about different scenarios and give you guys some considerations if replanting is necessary. This one is actually very nice because the group worked with the risk management agency, where we worked with them and provided available data on all the planting day trials for the states, and we were able to work with them, and RMA actually, a few years ago, they adjusted the early planting dates for the United States, right? So for Illinois, that's what it looks like right now, right? So it's broken up in three regions in the state, right? So the southern region is the green part here. The early planting date for for soybean moved from April 15 to April 5th, right? And you can see for the central and northern Illinois. So that was a very neat outcome with the project. Again, this is the 5 fact sheets that we published last year. And you can see that we're trying to cover a wide range of topics. These are kind of a 2-page fact sheet, not going into much detail, just providing you some what we know about, for example, we have one on nitrogen fixation, interpreting agronomic data. I think that was very nice. I think that can help folks on when they look at research or results from other research and help them try to interpret the tables or figures. We have one about cover cropping. Again, they're here available, so please grab one before you go. In terms of amplifying the extension impact, I'm going to start by showing our website. So right now, our website is housed within SHRIN, which is the Soybean Information, Soybean Network and Information Network. Sorry. Soybean Research and Information Network. So if you Google Science for Success or SHRIM, it's going to get you to the website, right? So this is just a print of the homepage for SHRIM, and you can see on the top where the icons are, there is an icon for Science for Success, right? So if you click there, it's going to get you to the homepage for our website, and that's where you can find all the other resources that we put together. Right, so we kind of based and categorize all our extension materials into different, the different parts of the growing season, right? So if you go crop planting, you're going to find a lot of information or resources on pre-plant, trying on variety selection, planting dates, and that kind of stuff. We also have our winter webinar series, right? So I guess this is a good opportunity to show you guys and save the date, right? So we've been doing this for a couple of years now. In 2022, we started with a 1-day series where we talked about crop growth and misconceptions around different growth stages. Last year, we talked about key to early season soybean success. That was a 3-day webinar. And this year, our webinar is going to be on February 28th and March 14th, right? So the overall topic here, we're going to try and talk and discuss some of the weather and economic challenges in terms of soybean production. So save the date. More information is coming later with a link for registration. All our webinars are free registration, so very convenient for you guys. Again, we try to leverage social media too to have a bigger impact. So we do have a YouTube channel, which is actually, if you want to go and watch some of the presentations from the winter webinars last year, that's where you can find. You can find all the other videos that we recorded. So we usually record videos talking about soybean growth and development, some of the misconceptions around soybean growth. We also try and record some videos talking about some of the projects that we're working on and why we're doing that. And once the project is completed, then we try and provide some just brief summary in terms of a video. So they're not very long videos, so it's very nice that you can see it in 5 minutes. You can watch a film. We're also present in Twitter, X, what it's called now. So if you use X, We actually try to be very engaging on that. We have posts pretty much every week where we're trying to kind of regurgitate some of that materials, providing links for folks that can go and find our resources. In terms of national trials, this is one of the examples of the coordinated national trials. I believe this was one of the first ones that the team put together. This one looked at foliar fertilizers on soybean grain yield and economic return. Right, so this was done in 2019 and 2020. If you see the map there, that's where all they have the locations for that study. So again, there is a fact sheet kind of summarizing the findings for that project. And if you go to the website or if you scan the QR code here, it's going to take you to that PDF. This is a list of topics, previous and current trials that we have with the team. And you can see that we try to cover a wide range of topics, all the way from nitrogen sulfur fertilization, nitrogen fixation. We do have a trial that we finished last year on biological seed treatment. I want to show a little bit of the data here in a minute. We have 3 new trials that we started in 2024, and we'll likely replicate that in 2025. Those are the 3 last one here. Looking at desiccation timing, harvest timing, and every time looking at soybean yield and seed quality. And we also have another one with cover crops, which is kind of being partly funded by the Iowa Soybean Association. So this is where I get to present some data for one of the trials, right? So this is a trial that we did for 2 years. Where we evaluated what the yield response of biological seed treatments, right? So the overall goal here was to identify situations where biological seed treatments improved soybean grain yield and profitability. Here is just a few informations about the trial. So we did that for 2 years, 2022 and 2023. We had 22 states participating in that trial. Across the 2 years, we had 103 sites, and you can look at that figure there. That shows you all where the locations are for those trials. We evaluated between 9 and 11 products that were already available in the market, right? So those were small plot trials, randomized complete block design. The number of replications, we had between 6 and 8, depending on the site. So we really did give a shot on this project, right? So increasing the number of replications to try and see if we can pick differences if they really exist. Illinois in particular, we had 2 sites, one in Urbana and another one in Monmouth. And this was partly funded by the United Soybean Board, and we also got additional funding from the USDA to complete this work. So just a little bit about biological seed treatment. Again, not going very into much detail here, but basically it's a growing market, right? So we've been seeing a lot of products coming out on the market and being marketed to farmers. Some of those products, they are being marketed as a way to improve nitrogen fixation. They can assimilate phosphorus from organic or inorganic sources, all the way down to control of disease and nematodes, right? Increased grain yield. So this is a list of some of the active ingredients that we actually tested, right? So a little bit more into detail. We had products with azospirillum, which is kind of a free-living nitrogen-fixing bacteria. A bacillus that can promote plant growth by improving nutrient supply. The Brady rhizobium, this is nothing new, right? Everybody should be familiar with that. That's the bacteria that we have, the symbiotic relationship with soybeans. And there are some other microorganisms here that have actually been tested under their field scale. This is a list of the active ingredients for our treatments, which were basically products, right? So here I'm not showing the product name itself. I think that's out of the scope. But we tested 9 different products, and you can see that They range from like a single microorganism or to a mix of microorganisms. There were 3 new products that we tested in 2023 because of just we couldn't get a handle of the products. All the products, I believe, got donated to us, so they came from reputable companies within the country and even internationally. So going a little bit into the results, this is what the yield from all sites combined look like. This is yield from 2022, right? So what I'm showing here, it's a box plot that kind of shows the distribution of the yield across all the 103 sites. So if you look at either of those treatments, and they're numbered, right? So each black dot that you see on that picture, that's actually the yield from one of the replications, right? So for 2022, if you look at the box plots, they all seem very, very similar, right? So if you look at the distribution, we see yields all the way below 25 bushels per acre. We have a few sites that we saw yields above 100 bushels per acre. But if you look at the average there, so the average is that red number on top of the box. They're very close with the control, which is the last one there. This is the same figure, but looking at the yield data for 2023. And you can see that they're very similar, right? So the distribution of yield between treatments were very similar. In 2023, we actually saw higher yields in some of the sites, right? So if you look at the upper top of the box plot, you can see a few dots there where it's close to 115, 120 bushels per acre. So basically, when we combine all the data together and we look if there was any significant difference in terms of grain yield, we didn't find a single product that consistently increased grain yield when we compare to the control treatment where we didn't have any biological seed treatment. You can see the first graph there on your left is 2022, right? So I think that's a bar graph showing the average for every treatment. You can see they're very similar to each other. In 2023, we did see a significant impact. Our treatment number 3, which is the bradyrhizobium, had the highest yield. But again, when we compare with our control treatment, we didn't see that. We saw that and no product actually improved yield. Treatment number 9 decreased yield compared to the treatment number 3. So I guess that's one of the differences that we found in that study. So that's all the sites combined, right? But again, one of the objectives of this study was to, okay, is there any specific environment or soil conditions that it's going to be more responsive to biological seed treatment? So what we had a student, a PhD student out of Ohio. So what he did, he kind of clustered sites based on soil type and environmental, mainly precipitation, right? So we came up with 4 clusters, right? So I don't know if you can see, but the picture should denote where the clusters are, and the bar graphs there shows the average yield for each treatment within that cluster. Right, so when we do that, again, we didn't find that any significant differences in yield between treatments for each cluster. What pointed out to us is that cluster number 3, which is the blue sites there, which is all the sites in the upper Midwest, tended to yield higher than the other clusters. This is looking specifically for the data for Illinois. Right, so this is a table that shows the average grain yield, and we have our product list there, 2022, and for each location. Again, even when we looked at the individual sites for Illinois, we didn't see any significant impact of the anti-biological treatment in terms of improving soybean grain yield. So some of the key takeaways that we have for this study is that, again, all the studies were conducted on replicate how a farmer might utilize these products, right? So we did follow the label for all the products and apply them accordingly. Some of the products even suggested applications within 24 hours of planting, so we were able to do that. We tested in a range of products containing a range of combinations of biologicals. Of course, there's no way that we can test every known product out there, so the list that we have here is actually came from a farmer survey that kind of helped us select some of those products to be tested. And again, all the products came from reputable companies. We treated the products as labeled, and again, no significant seed yield differences between the untreated control and any of the products tested. And again, it doesn't mean that it's not going to work. I think we just need to keep testing. But I think the key thing is that if you guys are interested in these products or any other thing or any other management practices, one thing that it's good to keep in mind is that understanding the biology of the product and what it's supposed to do, I think that can help you guys to kind of place it where you think it's going to work, right? So you can see how this product can fit in your management system. And again, maybe try small, right? So if you want to test a product, I would recommend doing some strip trials where you can actually compare if that product actually helped with grain yield. So I'm going to stop here, and I think we have plenty of time for questions or discussions. I'll be happy to hear from you guys if you have any feedbacks or suggestions, not only in terms of the Science for Success, but any other management practices or challenges and issues that you've been seeing with your operation that you would like us to do a little bit more research, trying to generate data to help you guys. I'll be happy to get that feedback from you guys.
Is your research separate from the rest of the university, like Dr. Sybil's research?
Yes. So I'm developing my own program, but I'm happy that Connor is on board now. We started talking with each other. I think there's a lot of opportunities there to collaborate on trials rather than trying and duplicate work. At the end of the day, we're both agronomists. We're interested in similar things. So it's different, but there's still plenty of room to collaborate. Have you guys tested any biological seed treatment or any product that's coming out of the market lately? What has been your experience? Yeah?
So my experience with the biological products is I've tested a lot of different materials, and over the last 3 years of data in North Carolina, our response is the same. And this is on-farm, replicated strip trials, done the right way, but highly unreliable responses from one year to the next in between products. Sometimes they work, but knowing which one and when, we can't pin down.
Yeah, I'm trying to get that consistency. It's been challenging.
What is your plan for this year? What trials are you going to do?
This year I have a few projects with Illinois Soybean Association. One of them is looking at different fertilizer strategies for soybean following a cereal rye cover crop. We are testing two treatments in terms of nitrogen and sulfur fertilization. So one of the rationale there is that, and the discussion that we had on the previous breakout section on cereal rye, just uptaking some of the nutrients from the soil but not releasing back enough in a matter of time, right? So we know that cereal rye is going to tie up some nitrogen. There's a lot of research that has been done looking at corn falling zero, right? And looking at nitrogen management, if we can reduce some of that immobilization issue. We haven't seen many studies on soybean. Soybean has, again, nitrogen fixing the symbiotic relationship with braiding rhizobia, but they still take about 50% or 60% of their nitrogen it's taken up from the soil solution. So we were curious to see if that has an impact on soybean growth and development, and if so, can we supply some nitrogen early in the season that can help the soybean off to a good start, and then later on when it start nodulating, they're going to have enough nitrogen in the soil supply to fulfill the yield capacity. The other project that we have with ISA is looking at tillage systems by starter fertilizer too. So one of the areas that I'm interested in doing a lot of more work is looking at conservation tillage and conservation practices. So we're testing no-till systems, we're testing a strip-till system, and trying to understand what's the limitation in terms of soybean growth and development, and of course, yield. So we have another project looking at that. We have a big project in Christian County where we're looking at different cover crop species on corn soybean rotation. That's a more intense project where we're not only looking at the agronomics, but we're also measuring nitrate leaching in subsurface drainage systems. And we're also measuring nitrous oxide emissions, which is just another nitrogen loss pathway. So basically trying to understand a holistic approach to trying to understand nitrogen dynamics on those systems. Yep.
When you're testing these biologicals, are you performing a soil test beforehand to determine concentrations of the things that you're adding? Biological, because I guess my question is, if you have the things in there and you add a biological and you're just stacking on top of something that's already there, you probably wouldn't see a benefit. But if your soil is lacking, can you start looking in the soil analysis and saying, we could use these different biologicals to get in species of different, whether it's the microbes or the bacterias or whatever?
No, I think that's a very interesting question. We took soil samples in the spring before planting, but the only thing that we did was looking at soil fertility levels, and that's one of what we used to kind of cluster the sites into different environmental and soil conditions. I think you bring a valid point where, like, I guess we're still in the phase of trying to understand what happens when you introduce a single or a mixture microbes in the soil, right? Because if you remember your Soils 101 class, like there's about 10 billion microorganisms in a spoon of soil, right? So I think it will come with time, but I guess having a better understanding of, okay, you're including this strain or this new microbe in the soil, how they establish or how they compete with the other microbes that it's already in the soil, right? We know from soil microbiology research that looked at the community. They shift depending on management practices and crop rotations, and that takes time, right? So it will be, I guess, that might be something that we really need to work on and try to understand, okay, we're applying these products, are the microbes actually there? How are they establishing, and are they doing what they're supposed to? I guess that's perhaps the next direction that some of the research on that area I kind of might be looking into. I guess that's it. I know it's been a long day, so thank you guys for sticking around, and happy to interact with you.